Hello everyone, my name is Han Shengxiang and this is question 2 of homework 6 in the course probability and stochastic process. And in this question, there is a density function of xy is equals to b when x to the power of 2 plus y to the power of 2 is smaller or equal to 1. And for otherwise, the value is equal to 0. In this question, the first we want to find the b so that the density function is a valid density function, and so we could compute the probability of xy so is equals to 0 is equal to 1. So the integral of xy density function dx dy is equals to 1, and it's equals to, because of the x to the power of 2 plus the y to the power of 2 is like the circle function, and we could let the x is equals to r cosine theta and y is equals to r times sine theta, and it is equals to 0 to 2 pi and the d theta and the 0 to 1, the density function of xy value is equals to b times the r dr, and it is equals to 2 pi times b times 1 over 2 times 1 over 2 is equals to pi times b, and it is equals to 1, so the b value is equals to 1 over pi. So the density function of xy is equals to 1 over pi when the x to the power 2 plus y to the power 2 is smaller or equals to 1, and for otherwise it is equals to 0. And for question B, we want to compute the expected value of x in the condition of small y, the x in condition of big Y, and y in condition of small x, and y in condition of big X. To compute this, at first, we want to compute the expected value of x is equals to the integral of x times the density function of xy dx dy is, we could also use the circle function, let x is equals to r cosine theta and y is equals to r sine theta, and is equals to the integral of 0 to 2 pi d theta and the 0 to 1, x is equals to r cosine theta. The density function is 1 over pi and times the r dr. For cosine theta, the integral of cosine theta from 0 to 2 pi is equals to 0. So the value of x is equals to 0. And we could compute the expected value of x in condition of small y, and is equals to the integral of x times the density function of x in the condition of y dx, and the conditional density function is equals to the integral of x times the density function of xy over the fy, and it is equals to the integral of density function of xy is the x from the minus 1 square root of 1 minus the x to the power 2 and to the square root of 1 minus the x to the power of 2, and the fxy value is equals to 1 over pi, and the dx this is the value of y, and to compute this, it is equals to this part is equals to the x times this part is equals to 1 over pi, and this part is 1 over pi times 2 times this part minus this part, so it is equals to 1 square root of 1 minus the y to the power of 2 and the dx. So it is equals to 0 because the x is the old function and so for every y, the expected value of x is equals to 0. So the expected value of x in conditional of big Y for every small y, it is also the 0. And we will compute the expected value of y. The expected value of y is equals because of the symmetry, because it is like a circle part. The x and y are symmetry, so the expected value of y is equals to 0, and the expected value of y in condition of small x is equals to 0, and the expected value of big Y in condition of big X is also equals to 0. So it is and we want to compute the expected value of x times y is equals to the integral of minus 1 to 1 and the dx, and the y value is to minus the square root of 1 minus x to the power of 2 to the square root of 1 minus x to the power of 2, and the xy times the density function of xy is equals to 1 to the pi, 1 over pi, and the dx dy dx and it is equals to the it is equals to the zero, because for the y it is the odd function, and the interval of the y is symmetry about the 0 point, so the integral of this function is equals to 0. So the expected value of xy is equals to 0. And for question 3, the expected value of x times y is equals to 0 and is equals to expected value of x times the expected value of y. So the x, y are uncorrelated. So it is, we could prove that they are uncorrelated. That's all. Thank you.